Dear students, today we are going to see chapter number 3, Atoms and Molecules. The topics are laws of chemical combination, atom and atomic theory of matter, Dalton's atomic theory and atomic symbols. The whole universe is composed of elements, compounds and mixtures. At present, more than 100 elements are known, but the number of compounds known is very large. A compound is formed by chemical combination of the elements. The formation of a compound by the combination of elements is governed by the following basic 5 laws. Law of conservation of mass, law of constant proportion, law of multiple proportion, law of reciprocal proportion, and Gay-Lussac law of combining volumes. Among these, the law of conservation of mass and the law of constant proportion are considered as the two basic fundamental laws of chemical combination. First, the law of conservation of mass. Antoine Lavoisier, known as father of modern chemistry, established the law of conservation of mass in 1774. According to this law, whenever a physical or chemical change takes place, the total mass of the reactants is equal to the total mass of the products of the reaction. The substances that take part in the reaction are called the reactants, and the substances formed as a result of the reactions are called products. For example, 100 grams of mercuric oxide, when heated in a closed test tube, decomposes to produce 92.6 grams of mercury and 7.4 grams of oxygen gas. Here, the total mass of the reactants is equal to the total mass of the products, that is 100 grams. Hence, during the decomposition reaction, matter is neither created nor destroyed. Here, matter is made up of tiny mercuric and oxygen atoms. The given reaction shows that atoms can neither be created nor destroyed in chemical reactions. Now, the law of constant proportion. This law is also known as the law of definite proportion. It was given by French chemist Joseph Proust. It states that every pure compound always contains the same elements combined in the same proportion by mass. For example, water consists of 2 atoms of hydrogen and 1 atom of oxygen in the definite ratio 1:8 by mass. Now, we are passing on Dalton's atomic theory. John Dalton used the two basic fundamental laws of chemical combination, that is, law of conservation of mass and law of constant proportion, as the basis of his atomic theory. The following are the postulates or assumptions of Dalton's atomic theory. All form of matter is made up of small particles called atoms. An atom cannot be further divided into still smaller particles. Atoms can neither be created nor destroyed in the chemical process. Atoms of the particular elements are identical in all respects. Atoms of one element are different from those of any other element. For example, the atoms of the different elements can be distinguished from each other by the respective masses. Atoms of elements may combine in simple whole number ratio to form compound atoms, later called molecules. According to Dalton's atomic theory, atom is the smallest particle of an element which cannot be further divided and that retains all the characteristic properties of that element. Now, the drawbacks of Dalton's atomic theory. Dalton's atomic theory ruled the scientific world for about a century, but it has many drawbacks. The assumption that atom is indivisible is no longer true. An atom can be decomposed into three subatomic particles such as electron, proton, and neutron. Atoms of the same elements may not be identical in all respects. The atoms of the same elements may have different masses or called isotopes. The atoms of the different elements may be same in some respect or called isobars. Dalton's atomic theory fails to explain how and why different elements combine with each other to form compound atoms. Now, what is an atom? An atom is the smallest particle of the element which cannot be further divided and still retains all the characteristic properties of that element. How big are atoms? Though the atoms of different elements have different sizes, they all are extremely small. Normally, atoms do not exist independently, but are found in combined state, yet we have methods to compute their sizes. The size of an atom is normally indicated by its radius, which is called atomic radius. Atoms are so small that they cannot be seen with the naked eye or even by a powerful microscope. An instrument developed in 1981 is called scanning tunneling microscope. This can produce magnified images of the surface of the elements. Now, atomic symbols. A symbol is a character or figure that represents an idea, word, object, or concept. Alchemists were ancient chemists who used strange symbols to represent elements. Dalton's atomic symbols. John Dalton followed alchemists in representing the elements pictorially with the help of circles. He made an important advance of letting the symbols designate symbol atom of the elements. The atoms of different elements were differentiated by different marking on these circles. The compound atoms, later called molecules, were symbolized by a group of circles. The Swedish scientist Berzelius proposed in 1813 that chemical symbols of the elements should be based on their Latin names, a proposal generally adopted. Modern atomic symbols or chemical symbols. A chemical symbol is a shorthand notation derived from scientific name of a substance. Modern system more or less follows the guidelines of the Berzelius system. Normally, the symbol of an element or atom is the initial letter of its common English, Latin, Greek, or German names. This letter is written as capital letter. For example, symbol of nitrogen is N. For potassium is K from kalium. In case the first letter is same for two or more elements or atoms, a two-letter system is used as a symbol for such atoms. The symbols of such elements are represented by the first letter followed by some prominent letters from their names. The first letter is written in capital letter in the uppercase, while the second letter is written in small letter in the lower case. Nowadays, IUPAC approves the names and symbols of the newly discovered elements. Thank you.